Good evening, students. Today I am going to discuss one question in AS level physics. This is actually a past paper question. Shall we solve this question? Look at this. Take a paper and pen and solve by your own way. After getting that answer, please check whether you are getting the right answer or whether you are doing the right method. You are applying the right method like that. So take a paper and do that. Without doing by seeing that video itself, you won't get any creativity and you won't get any solving power for the sums related to this concept. So you have to do of your own way, whether it may be right or wrong. You should do with your own way. After that, you have to check whether your answer is right or not. Okay, let us do that. So I think you have done that sum. Pause that video and please do that one. After that, once again, please check what are the steps we are taking to solve this problem. Let us do this one. A car of mass 1500 kilogram moves along a straight horizontal road. The variation with the time t of the velocity v for the car is shown in the figure. Okay. So in the graphical way, they have shown the velocity and the time graph. That is, movement of car has been shown in the velocity time graph. Time has been given in the x-axis and velocity is in the y-axis, right? So what they are asking, the brakes of the car are applied from t is equal to 1 second to t is equal to 3.5 seconds. So the brake has been applied from t 1 seconds to 3.5. So total time they have applied the brake for 2.5 seconds. After that, they are asking calculate the distance moved by the car at the time of brakes applied. So at the time of brakes applied, we need to find out the distance. So for the distance, we are having one formula, S is equal to ut plus 1 by 2 at squared. What is that? S is the distance and time already we found, and then A is an acceleration. So we need acceleration for that one, right? But we don't have acceleration according to that graph. So we are going to apply that formula. We are going to apply the graph to the formula V is equal to U plus AT. So negative acceleration will be there, right? Because they are applying the brake. But anyway, what is the initial velocity? Initial velocity is 32. Look at this. Initial velocity is 32. So I'm going to take that initial velocity as 32 and the final velocity is this one. That is, it will be 18, right? So 18 plus 80. So from that formula, we can find that AT will be minus 14. So T is already, T has been given already. That is why A will be equal to minus 14 divided by 2.5. So if you are doing that one, what you will get? 14 divided by 2.5, right? So 14 divided by 2.5, that will be 5.6. So acceleration we found, but negative acceleration because we are applying the brake, right? So we are decreasing the speed. That is why we are getting the negative value. So acceleration is in the negative value. And then now we have found only the acceleration, but we need the distance, right? So S will be equal to, the distance will be equal to UT. U is a 32 and time will be 2.5 and then 1 by 2 into, instead of A, we have to write minus 5.6 and T square 2.5 into 2.5. If you are solving this one, I think you will get 62.5. I will check that. 32 into 2.5 will be 80, right? So this will be minus 2.8. So 2.8 into 2.5 into 2.5 will be 6.25, right? So 17.5. 80 minus 17.5. What is the answer you are getting? 62.5. So the answer will be 62.5 meter. And then next thing. Calculate the magnitude of the resultant force. Resultant force is nothing but the mass into acceleration. Mass of the car they have given, that is nothing but 1000. What is it? 1500 kilogram. Yes, the SI unit of mass is kilogram. So we can take that as such. So mass into acceleration we already found, right? What is that? Minus 0.56. Okay. And then 1500 into acceleration will be 5.6. That is, the resultant force will be 8,400 Newton, right? 8,400 Newton. And the C part. In that C part, they are asking the acceleration as well as force direction, right? So acceleration will be at time 2 seconds, right? When the time is 2, we are applying the brake. So acceleration will be negative, right? So acceleration, negative acceleration means we are applying the brake, then acceleration direction will be like that. So, and the force we already found, that is minus 8,400, right? So the force will also be, acceleration and force both will be at the same, both will be in the same direction always. But the direction of motion will be opposite to the force and the acceleration. So this will be capital A, because they are asking us to label capital A. Thank you.